is the mounting, file system mounting. Oh, yeah, this is what if I connect this one to any computer? Can you see the file? Yes, definitely, because it's a USB. That's the benefit of universal. Then, how can you see the file? Even sometimes it can be seen as the removable drive, the Z, the removable drive, the F, removable. Sometimes it's the macOS. How can you see? Because the file system itself is not absolute the path. Okay, so from top of this file system, it has the relative, which means it can be part of the directory of the other file system. That's the benefit of flexibility of the file system. How can we implement such a thing? Using mounting. Mount. So let's see this example. If I leave here, probably I forgot. So this is our file. Okay, file system is starting from the root because it's the general graph structure directory is starting from the root, under the root, user, and so on. Okay, the triangle means it's the subdirectory, the sub file system. I have another one in the hard disk drive, okay, or the external hard disk drive. So can I use this file system in the existing mostly local file system? Yes. How? We can mount this point, the root of this point to the file directory, any of the file directory in the local. How can we do that? Using the mount option in Unix and Linux. Okay. What about the Windows? Windows, you can. If you are using the USB, it's automatically recognized, assign one of the C, D, E, F, G among them. But here Unix is still used, so you need to specify the mounting point. So this is called the, for example, if I don't want to use the head, instead I try to plug in to this file system here. This one is called mounting point. You can mount anywhere if you want. So
what happens to help?
you should not, you cannot delete this thing. It will be gone. Okay? If you mount this one. So, for example, so this is an example of the mounted. There are so many in this example. Even root is mounted on the device disk, the cylinder number 0, track number 0, and so on. This is mounted. Okay? Option is read write. Okay? And even you can specify the same user ID who is the owner and how many large it allow the large file. You can specify the option of them. Even root is mounted with this hard disk drive. And also the PROC file is mounted and so on. You can see some of the network mounted even remotely, NFS. So this is the mount option. So let's see the virtual example on the virtual machine.
What is the last one?
OS. So you can see the even this one use the where did I type the mount? So 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9 file system are mounted on one. This is a simple system. Okay, that is the mount. You can unmount. What will be the command? U-mount. You can U-mount.
So all file systems are different, right?
Yes. So this is the mounting. You can see. How can you read? The root has the DEV SDA1. It's a hard disk drive. It's mounted on the root, and temporary TMP FS mounted /lib/init and so on. So actually most of the current file system mount a lot of different file systems. Okay. So if you test the exercise lab PDF file that I upload the Canvas, you can test such a basic command. If you have a struggle to understand the specific command in Unix, the best way is this command. Okay, what is this? Manual. Okay, so if you want to know something, the mount keyword, you can search man minus k keyword. Or if even you do not know how to use the man command, this is a study. So this is the best way to understand, to learn the Unix and the Linux system. Really, this is one of the very helpful, the most helpful, the help command, I believe. Okay. This is you can see the different way using the df. You probably know that this command, the df minus k, is the data file, the size with the kilobyte, the unit scale. So you can see such a thing. Zeus is the remote amount. Then there are a couple of more things that we discussed in the file system. One is the file sharing, and another one is the file protecting. File sharing, I don't think the Windows and Unix are very powerful to protect their file. Because of that, unless if you know the user ID, any user ID, then you can access the file. The reason is that their file permission is what the protection, sharing or protection is based on just nothing but user ID and group ID. Two the thing, user ID and group ID. So in multi-user system, each user has their own user ID. It's not username, it's a user ID. So for example, when I mount this one, the file has the JELE. Okay, it's my username. But in his system, I'm using the JAY, the username. So can I plug in this file? Can this system browse this one? No, because it's different user. So JAY cannot see. Instead, what is the user ID of the disk? It's a 500, for example. It's a user ID. Then, in this, the system, if any user who has user ID 500 can read it. Okay? That is the file sharing and file protection in the operating system. So you should be careful. So when you have the multiple system, like we have the 10, the server, when you create the user for each server, sometimes you need to do that. You can just focus on sometimes username. No, user ID should be same. Okay, UID is the most important. Similarly, group ID is the group of user. You can assign the group ID, like the faculty group, student group, or something group. Okay, group ID is the same, even though you have give the same group name, but with a different ID, you cannot access the file. So you should be careful. So that is a user ID and group ID. So how can I see such a file? For example, if I type ID command, my user ID is 1000. OS is the username, but username is separate, is not very important in security. Okay. User ID. Group ID is the 1000, is the operating system group. How many group ID? It can be many. For example, I can belong to the computer science group, CSC. Also, faculty group. Also, whatever the group. So I can, user ID is one, but it can be many groups. So that is the reason it has 1000, 24, 25, 29, 30, and so many groups are assigned to user. But if I have the same system in other operating system, but if you want to access such a file, the ID should be same. Even though username is different, it's okay, as long as ID is the same. and group ID is the same. So that is the way to protect. And also, when you share the file or the directory, it's the same thing. You need to have the permission for that user ID and group ID. So this you can see the user ID and the group ID from here. Sometimes you can see the number only instead of the username or the ID. That means that is assigned for 400 group, but 400 group is not the informed in this operating system. In this operating system, the does not know what is the group name of 400, but still manage the permission with the group ID. Okay. It's okay to share the file, the local file system. You can give the permission. We will see how to give the permission and for the group or the other user. Okay. But the problem is the remote file system. Remote file system is the same mechanism. As long as you have the same, you have the permission for the specific group ID, user ID, you can access the file. But at that time, one more thing you need to consider is the network problem. So how can, for example, while you are writing data, what if the network is disconnected? So you need to have the consider client server model for the writing and read the data. That's the only thing you can consider for the remote file system. What is time? 4 more minutes. Okay. That's called the failure mode. So your network file system should have the capability to recover in case of the network failure. Okay. For protection, in operating system, the file system, there are different. The permission, like in this case, the read, write, execute, append, delete, delete, whatever, it can be summarized as the 3 parts. Read, write, execute in operating system. Read, write, execute. So 3 different permissions. Sometimes it can be modified, okay? It can be modified and read, but there's read only and modify. That includes sometimes execute, but generally 3 access permission. 3 types of access permission: read, write, the execute. Okay, how can we represent such a 3? So for each owner, so my file, read, write, execute. And for the group, read, write, execute. And general, any user, read, write, execute. How many different permission? 9 different permission. Read, write, execute, read, write, execute, read, write, execute for owner, group, and public. Then, to simplify such a permission, we are going to use the execution is read, write, execute. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Then if you have the permission 1, now permit 0, permit 1, then times, that is 1, that is it's a 0, right? That is 4, total 5. So this is the 5. So in this case, the 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So it's a 1, 1, 1 means read, write, and execute permission. Total how much? So 7. Right? 1, 2, 4. What about this one? Read, write permission, not execute. That is 2 plus 4 is a 6. And only execution permission, that is the 1. So when we are saying owner access is a 7, group access is a 6, public access 1 means execution only. 6 means Is there, and how can you make the 6? Using 2 to the power. 2 plus 4, that's the only way. Right? So 2 plus 4 means 2 plus 4, read, write. And 7 means 1 plus 2 plus 4. That is read, write, execution. So for the owner has all permission. For other group has read and write permission only. For public, only execution permission. So how can we assign, specify such a permission using this command, change mode. CH mode, 761 means this one. What about the 661? Owner 4 plus 2. That means read and write, and execution permission. Using such a number is a very smart way and still use most of the Linux and Unix, the operating system. Okay? So this is a permission. Group is the same. Group, CH group. What about the Windows? Windows is a little bit simplified. You can have, it has also the group permission, security tab. So you can give the full control, modify, read and write. But basically it's a read, write, execution. So if you see the Linux file, let's see the last one. So you can see read, write, app, which means this is the user 7. RX means group. This is user, group has. How can you make the RX means 4 plus 1, 5. RX 5. So it's a 755. So you can make this permission change mode 755 to this 5. You can specify so that when you are using the Linux or the Unix based, including macOS, you can actually change the permission using CH mode command. Okay, that's one of the difficulty when you get familiar with the graphical user interface. That graphical user interface actually implement this idea. Okay, then there's one more thing. Yes. So total 10-digit permission. So 3339 and plus the beginning. What is this? Can you see it? So this one. You can see there's one more D. What does it mean? Directory. Okay? Directory. However, directory does not have execution. What does it mean, execution? List of one. Okay? List. So when you access such a list of the file, then that's not the main problem. Sometimes you can see S, smallest, sometimes largest. Anyone who ever seen the smallest, largest? Okay, so it's a homework. Why don't you search? I don't want to give the name of that. If I give the name, it will be very easy to find from the Wikipedia. So why don't you search? Then while you are searching this information, you probably can understand the basic mechanism of the file protection in operating system. Okay? So by next week, the Tuesday, handwriting only. Okay? So why don't you find what is the smallest and largest in the file permission? No more than the half of the page. Okay? Do not write the paper. Just a very simple. The definition of S and large S. Okay? What is that?
Turn off the system?
Throughout the system?
Turn off the system?
Yes, in operating system for file permission.
How about now?
It's a homework. You don't have to submit it, just bring your homework. Then that will be also your attendance check for next week. Okay, thank you, and see you next week.